pH, another section where you need to keep that scientific calculator handy because pH is negative log of the hydrogen ion. So we're going to be using that log key right there to the left of the 7. Now, significant figures for pH are unique. And you will probably catch me making some mistakes in it, please. If you do, speak up. So significant figures for pH. pH gets the same number of digits after the decimal as the total in the coefficient because the number before the decimal came from the exponent. So if we have pH, we can also do POH, pKa. See, the format is the same. And we have another relationship. pH plus POH gives us 14. Now the pH scale you're probably familiar with runs from usually 0 to 14. Acids are the low, base is the high, 7 is neutral. So let's look at these. Given the H+, find the pH. Given the OH-, find the H+, like we did in the last segment, and then find the pH. Okay, so let's look at these examples. And these two examples are similar. They each have a coefficient of 1. And look what happens to the pH. We've got 1 times 10 to the minus 5, and pH is 5. We've got 1 times 10 to the minus 8, and pH is 8. We did it on the calculator. Negative log of 1 times 10 to the minus 5. See, we get 5. Calculators can't do significant digits. So when the coefficient is 1, all you have to do is take that exponent and make it positive, and use the right number of significant digits based on your coefficient. Now these two, coefficient is not 1, so we're going to bring out the calculator. We're going to do the exact same thing. Negative log 2.5 times 10 to the minus 5. Huh? We rounded it to 4.60 because of 2 digits in the coefficient. Now look at these. 1 times 10 to the minus 5 gives us exactly 5. 2.5 times 10 to the minus 5 gives us a little less than 5. So you can always use the exponent to estimate. Okay, so let's do these down here that don't already have the answers. I'm going to use my second entry again so that all I have to do is change my... There's the problem. Sometimes it jumps. All right. So we have 3.8, and we have 10 to the minus 4. So that gives us 3.42. A little less than 4. And then we have our last one here, 4.6. Times 10 to the minus 12, so we can predict that it's going to be a little less than 12, so 11 point something. It is indeed 11.34. Now, using the fact that pH plus POH is equal to 14. pH is 10, POH is 4. pH is 3.49, then POH is 11.51. If pH is 7.43, then POH is 14 minus 7.43, which would be 6. I'm having a blank, 57. Since I had a little brain blank, I'm going to try it on the calculator to make sure. All right, good. pOH is 6, and pH is 14 minus 6, which would be 8. Now, if we want to get the H plus from the pH, we need to take the antilog, because pH equals negative log of the hydrogen ion. So we have to do negative pH equals log of H plus. And then we need to take the antilog of both sides. And antilog is 10 to the... So when you take the antilog of a log, the log goes away. So what we're doing in the calculator is second log. So if pH is a whole number, it just becomes that negative exponent. Because if you do 10 to the minus 10, well, then you can write that as 1 times 10 to the minus 10. But if you're doing 10 to the minus 9.39, well, you can't just write that down. You've got to let the calculator put that in regular notation. And you always want to use second log to get your 10 and see it's ready for your exponent. Negative 9.39. And so there, 4.1 times 10 to the minus 10. So let's look at the others. Now notice, H and H match, H and H match, OH and OH match. Okay? They have to match to be able to do this. So we have second log minus 7.39. So we get 4.1 times 10 to the minus 8. Okay. The exponent gives you the number before the decimal, and the coefficient gives you the numbers after the decimal. So if pH equals 4, 10 to the minus 4, well then all we have to do is that. 6.6, we got to use the calculator. So second log negative 6.6, we get 2.5 times 10 to the minus 7. Actually, significant digits, we're only allowed it to be 3 times 10 to the minus 7. And now if we do negative 2.539, we've got 0.00289. Let's put this in scientific notation. So that would be 2.891 times 10 to the minus 3, and that's 3 digits after the decimal, so this should be 3 digits total. So I need to erase my 1.